And welcome to your neurofeedback expert practitioner's office. I'm Dr. Trish Leigh, and I'm here to make sure that you know how to interpret your qEEG brain map. Okay, so let's get started. The first thing I want to share with you is that our brains have been mapped by neuroscientists so that we know what every area of the brain is supposed to be doing in terms of jobs or skills and abilities. So this is an example of an international system that brain professionals use to be able to communicate with each other about how a person's brain is performing. It is called the 10-20 system, if you'd like to look it up. But what this image shows you is that up here at the front or the top of the screen is the front of the head. You can see the nose here. This is the left ear over here on the left side, the right ear on the right side, and the back of the head towards the bottom of your screen. What these bubbles indicate is what each area of the brain is performing. So for example, the letters on these circles indicate the area of the brain. F is for frontal, C is for central, T is for temporal, P is for parietal, and O is for occipital. And so you will see here, FP means prefrontal, that up here in the frontal area, we have attention and working memory, executive function, which is planning and organization. Over here, we have impulse control and judgment. Moving back a little bit further, we have the sensory motor cortex, which is responsible for the integration of sensory input and motor control and output. On the left-hand side of the brain are the language areas, language production up here called Broca's area, language comprehension and verbal comprehension back here, Wernicke's area. In the temporal lobes, they're responsible for auditory processing, and they're very strong emotional regulation areas. Towards the back in the parietal lobe, we have cognition, more verbal on the left, more mathematical on the right. Moving even further back is the occipital lobe. It is a hub of neurons with lots of long neural connections up to the frontal lobe, and it controls visual processing. So hopefully you get the gist that when we see speed being used improperly in one or more of these areas of the brain, a person's symptoms results. And so, of course, this is a simplified version of the 10-20 system. But again, if you'd like to look it up, there's lots of information about it on the internet. So let's move on. We've just covered brain areas. Now let's think about brain processing speeds. They're known as brain waves, but I like to think of them as processing speeds because I think it helps people understand. Our slowest speed that we're going to consider is called delta. It is extra slow processing speed. And you will see here in the first column, when it's being used properly, it keeps your brain in deep sleep. In the second column, we will look at improper expression. And when we see delta involved, it can mean that there's a head injury involved or some type of trauma. Moving on to theta is slow speed. So when slow speed kicks in, that is what shifts us into sleep when we have proper expression. If we have too much of theta, it's implicated in many of the challenges that people have. So theta is the biomarker for ADHD. It creates brain fog. It creates dementia symptoms. And you'll see here when there's head injury, it's also involved. The brain slows down too much. And when it uses too much slow processing speed, it's not able to process information in real time. Next is alpha. Alpha speed, I like to call it couch mode. So when it's being used properly, it really helps your brain to be calm and relaxed. So think of it this way. If you were to go and sit on the couch for a minute and just chill and do nothing, your brain would slow down to a perfectly relaxed speed. And that's proper expression. When it's being used too much, if you're always stuck in couch mode, it's depression. So you can see that optimal alpha is at about 10.5 hertz. That's 10.5 cycles per second. Now moving even faster, we have 3 bands of beta. The lowest beta is what I always call perfect processing speed, which of course there's no such thing as perfect processing speed, but there is perfect processing speed for calm focus. It is low beta. And you will see here that it's involved in relaxed attention. And if it's being used too much, it can result in chronic fatigue. A little bit faster beta is when you have very focused attention. And if you use too much of that, then you will not be able to fall asleep. The highest, fastest beta is what you use when you are in fight or flight or something very stressful happens. So if you have a major stressor in your environment, your nervous system will kick it into overdrive, as I call it, which is perfectly appropriate under a very stressful situation. But then your brain should be able to come down to fast and a little bit slower fast speed in the lower betas. And then you should be able to get your work done in calm, focused attention. Then you should be able to go to lunch and relax using more alpha. Then you should be able to go home at night and get in bed and have your brain start shifting into sleep, and then have it kick into delta and be able to sleep 8 glorious hours. So that is called circadian rhythms. That is how these speeds are supposed to work. Unfortunately, when improper expression is evidenced in a brain map, it means that a brain is stuck in a gear. So I like to use the analogy of a 10-speed bike that you can switch the gears, and you need to switch the gears appropriately depending upon how you're riding in terms of hills or flat ground. The same thing applies to your brain. You should be able to shift these gears easily and seamlessly throughout your day. If you suffer from anxiety, you are stuck in extra fast mode. If you suffer from ADHD, or if you have dementia, or if you've had a head injury, you are using too much slow speed. And unfortunately, brains can be stuck in too much slow and too much fast speed simultaneously. We wish they would average out into perfect processing speed, but they do not. So this is what your brain map will show. So this is an example of a brain map. There are 4 main parameters that your practitioner will review with you. What I was just speaking about in terms of brain speeds is located up here in the parameter of magnitude. Magnitude shows how much of delta, theta, alpha, and beta your brain is making. This is just an example, but in just a moment, your practitioner will share your brain map with you and review these parameters with you. On this example, you can see that this brain is making much too much delta. How we know that is you can see that yellow indicates very high use of a speed. Red indicates high use of a speed. Green says okay, and that indicates optimal brain performance. Light blue indicates low use of a speed, and dark blue indicates very low use of a speed. And remember from our last video together that how this is being measured is your brain is being measured being compared to a very large database of optimal brains. So when we see a color and it says that your brain's use of delta is very high, that is compared to the optimal brain performance pattern for your age. So in this example, this person's brain is using much too much delta, very high, all yellow, much too much theta, especially in the frontal lobe. It's high across the board. It's using much too much alpha in the frontal lobe, and it's blue in beta in the back. And this is a classic ADHD brain map. You will also see that we will see a parameter called asymmetry. What we want to see is the brain having more use of the slow speeds on the right side within the right hemisphere. And we see that here. Delta, theta, and alpha are all red on the right-hand side. Beta, we want to see all red on the left-hand side. And in this case, you can see that some of the betas are switched, where there's blues where there should be red. That is called a beta asymmetry. Your practitioner will show you if you have any asymmetries. Moving down to dominant frequency, I've already told you that at perfectly calm speed, the brain is running at 10.5. What dominant frequency will show you is that if delta, theta, alpha, and beta are running at their perfect speed each. So here, alpha is mostly blue across the whole brain. That means alpha is not running at 10.5. It is running slower. So it's acting more like theta. we see theta's running slower, it's acting more like delta, and delta's running slower, which means it's running in its very slow version of itself. The betas we see are running too fast on the right-hand side and too slow on the left. Your practitioner will review your dominant frequency. We want to see all of these circles in dominant frequency being green, and that means that your brain is running at the perfect speed. The last parameter is interconnectivity. This parameter looks at how the brain areas are communicating with each other, specifically from the right hemisphere to the left hemisphere. Again, we want to see green circles down in interconnectivity. And when we do, it means that there's just the right amount and the right timing of communication between the hemispheres. When we see blue, it means that the amount of communication is low and the timing is slow. That's called hypoconnectivity. When we see red, it means that those areas are hyperconnected, means that they are performing too much in communication and sometimes too fast. What it always means in terms of interconnectivity is that communication between the hemispheres is impaired and your brain is not performing as strong as it should. Okay, so what we are talking about when we think about neurofeedback training to be able to regulate the brain map example that we just looked at together is called neurological regulation. So it's important for me to communicate to you the whole point of having your brain mapped is to see how far off from optimal your brain is performing, with the intent, hopefully, of regulating your brain towards the optimal pattern to break a downward spiral and create an upward spiral of permanent change. So the way that this folds out for you is if your brain shows neurological dysregulation by having the yellow and red and the blue colors on your map, it means there's room for improvement. And to me, that's good news. When your practitioner regulates your brain towards optimal, you will have stronger self-regulation skills. You will be able to improve the behaviors of your mind and your body to create permanent change. And why I'm telling you this is it's very important for success. It is called Hebb's Law, H-E-B-B, Hebb's Law. You can look it up. You know how I love people to look things up. What it says is neurons that fire together wire together. And what we are doing as neurofeedback practitioners is breaking a negative feedback loop that starts with a negative brain pattern that's dysregulated, get you negative behaviors, which get you negative outcomes. That's the struggles that you experience in your life. When we begin to change your brain pattern, and we don't even have to get it all the way there, we have to begin to change it, and you begin to see better behaviors in your life, and you're rewarded by better outcomes, we will take that negative downward spiral and we will create a positive feedback loop that science shows creates permanent changes for you. So hold tight. Your practitioner will be in a minute to share your brain map with you, but I hope this information helps you to be able to interpret it and understand what it means for you so that you can get on the road to neurological regulation so you can feel and perform better. Thank you for your time.